All right, good morning. What I am going to attempt to do for the next few minutes is try to show you where the triangle sum theorem comes from. So in other words, why do all of the angles in a triangle add up to 180? Is that arbitrary? And if not, why? So to start with this, what we need to do is we need to do a quick little review, and our review needs to cover parallel lines cut by a transversal. Now, if you remember anything at all about this, this is something I believe that's covered in 8th grade math. I normally teach it to my students. So assuming we have line A and line B, and they are parallel to each other, okay? And then we have C, which is our transversal, which is a line that goes through both of those, all right? So with this, you get a lot of little interesting properties that come around, and my purpose isn't to prove these to you today. My purpose is just to remind you of these, all right? And so you have all these really interesting angle relationships that come up as a result of this, all right? And so the big ones that you need to know is, first of all, like if you have angle 1, and then we'll call this angle 2, those are called corresponding angles. So those are congruent to each other, all right? So if you look at it, if you like picked this up and moved it over, if you picked this angle up and moved it over here, you would see that they're the same angle, all right? Similarly, there's other types of angles that have those kinds of relationships, all right? If I say this is angle 3, and I make that right here, well, 3 is equal to angle 1 because they're vertical angles. Most of you are good on that. And if angle 1 is equal to angle 2, then angle 3 is equal to angle 2. And these are called alternate interior angles, all right? Alternate interior angles. So 3 is equal to 2, and then if we set up another set of angles, you would have 4 is equal to 5. And I'm sorry, I'm using the wrong language here. I should be saying that the measure of them is equal to each other. They are congruent angles. So 4 is congruent to 5, 3 is congruent to 2. And then the other set of properties you have that you can use for this is angle 1 is also equal to, if I make this angle 6, the measure of angle 1 is also equal to angle 6, because if you think about it, 1 is congruent to 2, and if 1 is congruent to 2 and 2 is congruent to 6 because they're vertical angles, they're right across from each other, then that means 1 must be congruent to 6. So all these like transitive properties you can take and use in here that work well. So the big one we want to remember is this one, this alternate interior angles, all right? So now let's jump back. Let's look at our triangle here. So the very first thing you have to do when you're looking at this theorem is you have to, this is a very informal proof. I am by no means making this a formal 2-column proof, all right? I'm just kind of showing you how we get this. So the very first thing I'm going to do is I'm going to say, okay, how can I use what I know about those parallel lines and being cut by a transversal to help me out with this? So the first thing I'm going to do, all right, let's see how well I can do this, is I'm going to draw a line. That didn't turn out too bad. All right, I'm going to draw a transversal that goes through here, and let's assume that that's at the tip of A and it's not poking out a little bit, all right? So I draw this, and I draw this purposely so that this is parallel with BC, all right? And we can call this AD if you want. All right, now what happens as a result of this is we get some kind of weird things going on here, all right? And so one of the first cool things that happens is we get a few other angles. We get angle 4 right here, we get angle 5 right here. And so if you look at that, all right, so we've got angle 4, 2, and 5. Well, all of these make up a straight angle, right? So angle 4 plus angle 2 plus angle 5 all would equal 180 degrees because they add up. So you've got angle 4 plus angle 2, plus angle 5 equals 180. All right, so that's kind of useful. All right, so we're gonna operate off of this now to see what kind of things we can do. So the goal is to say to ourselves, why do we know that this angle, and this angle all add up to 180. Why is that? Why does that happen? So I know that, okay, well, I know these angles right here all add up to 180 because I understand what angles, you know, if you think of it as supplementary angles, even though supplementary angles is technically a pair. But if you have 4, 2, and 5, and you know they all equal up to 180, and you know that you have angle 1, 2, and 3 that are supposed to add up to 180 because they tell us this thing, if I can show some kind of relationship between, you know, 4 and 5 and maybe 1 and 3, because angle 2 is in this one and it's in this one. If I can show some kind of relationship between those angles, then I'm probably good. All right, so let's see what we can do. So let's go back and let's look at our theorems, right, or what we know. Well, if you look at angle 5, all right, angle 5 just covers this. Well, angle 5 is an alternate interior angle with angle 3. Okay? So if angle 5 is an alternate interior angle with angle 3, that means they're congruent, and that means that technically you could take angle 3 and you could substitute it in for angle 5. So let's do that. So we've got angle 2, and then instead of writing angle 5, we're going to write angle 3. And then if you look at angle 4 over here, right, angle 4 is an alternate interior angle with angle 1. And so instead of writing angle 4 here, you can write angle 1. And just like that, you have just shown that all three of these angles add up to 180 degrees. It really is that simple. That is one of the reasons this works. And if you didn't believe that this works, the other thing you could do is you could just draw any arbitrary triangle you want, all right, on a piece of paper. So you could just say, draw a triangle, and then cut the corners off. So, you know, cut that corner off, cut that corner off, cut that corner off, and then line them up. And if you do that, you'll see that you wind up getting this thing that's sort of like you got a piece here, and then you get a piece here, and then you got another piece here. And you'll get something that adds up to 180 degrees. So this always works. This is a theorem. It's like a law. So I hope this helped. If you want to see the formal proof of it with the actual names of the reasons that I used, you can ask me about that, and I can put something together for you for that. All right. Good luck.